actions mediated by the serotogenic receptors. So suppose this is your brain, and in the brain we have got a serotogenic neuron, and this neuronal end nerve ending will have got a vesicle containing serotonin. This is 5-HT1A receptor. When serotonin binds with 5-HT1A receptor, it will activate it. Even we have got 5-HT1A receptor agonist, that is buspirone, and whenever 5-HT1A receptor gets activated, it have got anxiolytic action, or you can say anti-anxiety action. Next we have got 5-HT1B1D receptor. Serotonin binds with it, cause activation, and what will happen? Yes, it will treat migraine. Similarly, we have got drugs such as triptans, even ergot alkaloids. They also act by binding with 5-HT1B1D receptor and treat migraine. Next, we have got a reuptake mechanism also, and certain antidepressant drugs will block this reuptake mechanism and will treat depression. See, we know serotonin is a neurotransmitter which is responsible for happiness. So we need to release the serotonin. If reuptake, too much of reuptake takes place, means it will go to depression. So many antidepressant drugs mainly act by inhibiting the reuptake of this serotonin. Next we have got 5-HT2A receptor, and we know if we activate this 5-HT2A receptor, means whenever serotonin acts or binds with the 5-HT2A receptor and activate it, what will happen? Yes, it will lead to psychosis. So we have got psychedelics such as lysergic acid diethylamine, which also activate 5-HT2A receptor and produces hallucinations. Next we have got 5-HT3 receptor, and when serotonin binds with 5-HT3 receptor and activate it, then what will happen? Yes, vomiting happens. So we have got certain antiemetics such as ondansetron that acts by blocking this 5-HT3 receptors. Next, suppose this is your blood vessel, and if we take a section of this blood vessel, it will look somewhat like this. This is the visceral smooth muscle. These blue balls are nothing but platelets, and inside these platelets is your serotonin. Now we have got 5-HT2A and 5-HT2C receptors present inside your blood vessels. When serotonin binds with 5-HT2A receptor, it will produce vasoconstriction. Serotonin when binds with 5-HT2C receptor, it will cause release of endothelium dependent relaxing factor, which is nothing but nitric oxide. And we know what nitric oxide will do. Yes, it will produce vasodilation. So this is the role of the serotogenic receptor on the blood vessel. Next, suppose this is your gastrointestinal tract, and if we take a cut section of intestine, it is look somewhat like this. This is the visceral smooth muscle, and of this of the lining of the intestine, if we zoom up this thing, we'll see the enterochromaffin cells, and these enterochromaffin cells contains your serotonin. Next, these are the neurons, the enteric neurons, and these neurons contains the receptor, that is 5-HT4 receptor. So whenever the serotonin present in the enterochromaffin chromaffin cells binds with the 5-HT4 receptor, or else we have got a agonist of 5-HT4 receptor, that is C-substrate, it acts as a prokinetics, means it increases the motility of the gastrointestinal tract. So this is